Okay, today we're going to be working with quadratic equations again. This time what we're going to notice is that factoring the equation, factoring the quadratic is not going to be a very useful way in actually solving the quadratic. The way that the quadratic equation is going to be written does not make it very useful to factor. So we're going to have to come up with another way to solve the quadratic equation. So what you're going to see here is that we are going to solve the quadratic equation by using the square roots. Now, in a pre-lesson that we've done, we have worked with radicals and square roots and learned how to simplify radicals and square roots and break them apart and put them together and so forth. So that is going to be a very important lesson in this particular lesson. Now, we'll get into more details about why factoring won't work and why we want to use square roots. But before we do that, I just want to go back and just kind of show you some basics that we may have touched on with the radical section. If you notice, if you get an x squared term equaling to some number, so in this little paragraph we talk about x squared equaling to x, I'm going to go ahead and use that but with a real example. So say we have x squared equals to 9. What it basically tells us is that we can actually have two solutions off of this particular answer. And remember, a quadratic is an equation that has a squared term being equal to something else. Now, in prior lesson, when we solved the quadratic using factoring, we tried to make the right side of the equation equal to 0 and then move everything to the left side of the equation so that we could factor the quadratic form. In this particular case, however, by working the problem, we do not necessarily need to move the 9 over and get it into factoring, even though that would be an option with this particular case. What we can do, however, is from where it stands, we can actually take the square root of both sides. So if I take the square root of both sides, you will recall that the square root and the power cancel each other out, leaving me just an x on the left side. Now the square root of 9, if you remember, is equal to 3. Now this is where solving for quadratics is going to be a little different than just simplifying radicals. If you remember at the beginning of that section of that pre-lesson, we discussed the fact that a square root actually has two possible answers. It has a positive answer and a negative answer, thus giving us this little symbol called a plus or minus sign. So you can see here that the square root of 9 is really plus or minus 3. So this is basically saying that x could equal to a positive 3 or x could equal to a negative 3. So this sign is just a different way of writing these two answers in one symbol. So this is very important because if you remember, the squared term of a quadratic, the x squared, indicates to us the degree, and the degree tells us how many solutions. Okay, so we know that when we take the square root of both sides, we're going to need two solutions, and the fact that we have a positive 3 and a negative 3 gives us the two solutions that we need. So whereas in the radical notes in the pre-lesson, we were just focusing on the positive version of it. Now, because we need two solutions, we're bringing in the positive and negative. So you'll be using the plus or minus symbol with the majority of the answers that you have. So let's start taking a look at some of the examples in solving quadratics. If we were just looking at this quadratic equation in example number 1, we wouldn't necessarily know right off the bat, do I solve this by factoring, do I solve this by square roots, or some other possible way that we're going to learn later on. The first clue is the way that it's written. If you recall, the standard form was written as ax squared plus bx plus c. What made this factorable in a lot of cases was the bx term. Now that's assuming we're not working with a difference of squares. So the fact that we had a trinomial here with a bx term allowed us to factor in most cases. What you're going to find is whenever we do not have a bx term, square roots may work better. Than factoring. So very important that if we don't have an x term anywhere in the equation and we cannot put this in standard form and we only have an x squared term with some other constant numbers, more than likely the square root method of solving the quadratic is going to be important. Now, the very first thing that we want to do is we want to approach this problem by getting the squared term by itself. So you can see we start with 2x squared plus 1 equals 17. We want to get that squared term by itself first so that we can then take the square root of both sides. And so this takes some basic algebra. So we'll see in the first step we're going to subtract 1 from both sides. Then we would have to divide 2 by both sides, and that's going to get us x squared equals to 8. Now we have the squared term by itself, which means that we can take the square root of both sides, very similar to what we did up here in the right hand corner. This time, however, when we take the square root of both sides, we get a plus or minus square root of 8. And square root of 8 is not a perfect square, so we have to use our simplifying radical rules to break this down. And square root of 8 actually breaks up into the square root of 4 times the square root of 2, which gives us a final answer of 2 times the square root of 2. Now, we've got to remember here, it's plus or minus because there are two solutions to the quadratic, because the quadratic is a second degree polynomial. And so you can see here that the solutions are the positive and negative version of that. Now, I will absolutely take plus or minus the answer as your two solutions. That will be perfectly fine with me. So let's get some practice doing some basic problems here. If you look at sample problem number 1, part A and part B, it says to solve the quadratic, then what you realize is that there is not an x term in either one of them, so we want to isolate the x squared term so that we can use square roots to solve these. So go ahead and pause the video and work part A and B at this time. Okay, so the very first thing I want to do in part A is I want to get the x squared term by itself. So I need to do some basic algebra to do that. And the first thing I'm going to do is I'm going to subtract 3 from both sides, which is going to leave me negative 5x squared equals to negative 12. Then I'm going to divide both sides by negative 5, which is going to leave me x squared equals to 12 over 5. Now, here we finally have the squared term by itself, so we can take the square root of both sides to eliminate the squared term. So that root is going to eliminate that power, leaving us x is equal to plus or minus the square root of 12 over 5. Now, we've done all of the work to get x by itself, but this is where the simplifying of radicals comes into play, and we have to break this down a little bit farther. So if we look at x equals plus or minus square root of 12 over 5, we can use our radical rules, and we're going to get plus or minus the square root of 12 over the square root of 5. Now, we have a square root or a radical in the denominator, so this is going to require us to rationalize the denominator. And you can see that all of these rules are coming back into play. So I'll come back up here. We have square root of 12 times square root of 5 is the square root of 60. And square root of 5 times square root of 5 is 5. Now, we have the square root of 60, and we still have to simplify the perfect square out of that. So it's going to be, plus or minus the square root of 4 times the square root of 15 over 5, and that's going to give us x equals plus or minus 2 times the square root of 15 over 5. And that is our solution to our equation. Now, there's two solutions here. There's the positive version of 2 times the square root of 15 over 5, and there's the negative version of 2 times the square root of 15 over 5. So this plus or minus sign is important when you write your final answer. If you don't write the plus or minus sign and you only write 2 times the square root of 15 over 5, you've then only given the positive version of the answer, and so you would only get half credit because you need the negative version as well to show both solutions. Okay? So let's go to part B here, and again I'm going to try to isolate the x squared term by itself. So I'm going to start by adding 30 to both sides, which gives me 5x squared equals to 100. And whenever I divide both sides by 5, I get x squared equals to 20. And then again, I can take the square root of both parts, which is going to give me x equals to plus or minus the square root of 20. Keep in mind, the plus or minus goes outside of the radical, outside of the square root term. So here we've got to use our simplifying radical properties so we can break square root of 20 apart. So x equals plus or minus the square root of 4 times the square root of 5, and x equals plus or minus 2 times the square root of 5. And again, important that we have both the plus and the minus, because that's going to give us our two solutions for x. And you can write it as the plus or minus symbol, or you can write each of those separately as individual answers. Okay, let's move on to another type of problem that will use the same idea but maybe a little different here. If we look at example number 2, the first thing we have that stands out is that we have a fraction involved. So if you recall from earlier lessons and maybe from Algebra 1, the first thing that I like to do with a problem like this is actually to clear that fraction out. So we're going to multiply both sides by the common denominator, which in this case is 3, and that's going to eliminate the 1/3. Now, this is very important difference here. Notice that when we do that, we don't necessarily have an x squared term. We have an x plus 5. That whole thing is squared. Now, we do not want to expand this. If we took this, and keep in mind this is a squared term, we've isolated the squared term. So just like we could take the square root of the x squared and eliminate it, giving me x, I can also take the square root of this entire term, thus eliminating it and leaving me with x plus 5. So we don't want to expand this and make it x plus 5 times x plus 5, because then we're just going to get into go in the opposite direction of what we're trying to accomplish. So very important here, sometimes your squared term is not going to just be x squared by itself. It may be a binomial that's being squared. Now, once we take the square root of both sides, we're left with x squared equals plus or minus the square root of 21. Now here's a place where you don't want to make a mistake in your answer. We have to subtract 5 from both sides of the equation. Now, when we do that, it's very important that we recognize that the negative 5 goes to the left part of plus or minus. Okay? We do not want to do this. X does not equal to plus or minus negative 5 square roots of 21, because keep in mind, this right here is incorrect. The negative 5 is being added to the square root of 21 or subtracted from the square root of 21, but we're not multiplying it. So keep in mind, this is where the negative 5 goes in front of the plus or minus whenever we want to move it over. So common mistake that you don't want to make there. Alright, well let's take a look at a couple of example problems. First of all, recognize they both have fractions, so the first thing you want to do is clear the fraction. Secondly, they do not have an x squared term, but they have a binomial squared, so we can isolate that binomial squared before we take the square root. You cannot take the square root until that squared term is all by itself. So go ahead and pause the video and take the time to work these two sample problems. Okay, so if we look at sample part A, first thing I'm going to do is I'm going to multiply this by 2, multiply that by 2. That's going to eliminate that, and so we're going to be left with x minus 2 squared equals to 16. Now, we've isolated the square term. Even though it's a binomial, we can still take the square root of both sides. And when we do this, that's an understood 2, and so that cancels out the power. In doing so, we get x minus 2 by itself on this side and plus or minus the square root of 16, which is 4. Now, this previous example where we talked about the negative 5 going in front of the plus or minus is extremely important here. I need to add 2 to both sides. When I do this, when I add the 2, it's very important that I add the 2 in front of that plus or minus. Now that's going to cancel out. So this is going to leave me x equals to 2 plus or minus 4. Now, 2 and 4 are like terms, so we can actually finish this problem by breaking it up into two separate operations. We can say that it's x is 2 plus 4, or x is equal to 2 minus 4. So what we've done is we've taken this plus or minus symbol in this case and we've broken it up into two different parts so that we can get two distinct answers in this case. And so because it is a quadratic equation, the term is being squared. We have a squared term in there. That means we have two solutions when we deal with a quadratic, and so you can see we get two distinct real solutions, x equals to 6 and x equals to 2 in this case. Okay, let's move to the next one. Again, we have a situation where we have a fraction that we need to clear. So the common denominator is 3, so we'll multiply 3 to both sides, and that's going to cancel out the fraction, leaving me x plus 7 squared equals to 24. Now, in this particular case, the x plus 7 is a binomial. It is being squared. That term has been isolated, so that gives us the ability to go ahead and take the square root of both sides. Keep in mind that's an understood 2, so that root cancels out that power, leaving us with x plus 7 equals to plus or minus the square root of 24. Now, I have to subtract 7 from both sides of the equation. Again, very important that I put that negative 7 in front of the plus or minus sign. Those are going to cancel out, leaving me x is equal to negative 7 plus or minus the square root of 24. Now, in most cases we'd be finished here, but again, simplifying radicals is an extremely important part of getting the correct final answer. So the square root of 24 can be broken down into simpler terms, so we must do that. So negative 7 plus or minus the square root of 4 times the square root of 6, and x equals negative 7 plus or minus 2 times the square root of 6. Now, this particular answer, negative 7 and 2 times the square root of 6 are not like terms like we had in the previous example. So there's no need at this point to break it up into 2 individual statements like we did in sample A. So at this point, since we cannot combine these terms, we're just going to leave this as our final answer. And it does represent both solutions of the quadratic because it has the plus and the minus symbol. So that would be your final answer for this quadratic equation. So one of the skills that you're going to want to learn that is extremely important before you get to your unit test on solving quadratics is how to recognize when to use square roots and when to recognize when to use factoring to solve the different types of quadratic equations. That is going to be an extremely important skill that you're going to need to develop as we go further into this unit. Okay?